Hi guys, and welcome back to Gaming Animation. So today we're gonna do an education video today. I know. Okay, so today we're gonna do the states of matter. So you know the states of matter. It's just solids, liquids, and gases. It's basically science, but there's a subject in science, and that's physics. So yeah, we're gonna go through that physics and matter. Okay. So solid is like nothing but uh, everything which is hard. Yeah. Everything which is hard, and liquid is nothing but like a glass of water, a glass of milk, rain. Yeah. And gas is like air, smoke, vapor. So these are gases, and oxygen and carbon dioxide. Okay, so let us start with solid. We're gonna see its. We're gonna see first matter. Okay, what is matter? See, matter is anything that has. Wait. Matter is anything that has mass and occupies space. Yeah, so matter is, all solid and all the solid, liquid, and gas. So it's all called matter, states of matter. Okay? So, okay, okay. So next, it has two properties. Okay, it has two properties. And that is that it has mass. That's its first property. And after that, it occupies space. Its second property. Okay, so now let's get on to the composition of matter. Okay, look. There are small particles, it's called atoms, okay? Let me show you something. Atoms equals to molecules, and that equals to matter. Get it? Atoms are so small that we can't even see it in the best telescope in the world. Can you see that? We can't see even matter, so yeah. Next thing, it's like there's something called intermolecular space. You see all of these, these atoms and molecules are arranged. These are arranged in such a manner that there are small spaces that you see. In these solids, you see, right? Some spaces, small spaces there. Yeah, I think that is called intermolecular space. So, all those small spaces, and there is another one. The particles of any matter attract each other. And that means the force of attraction between the particles is known as the intermolecular force of attraction. Of attraction. Okay, there we go. Yeah. Okay, so, the next one is the intermolecular force of attraction depends upon the intermolecular space. The greater the intermolecular space, the lesser will be the intermolecular force of attraction, and vice versa. Okay? So yeah, intermolecular space is nothing but the space between the particles of matter. Okay, that's all. Nothing else. Okay, now let's get on to solids. Okay, I'm straight away gonna say it. Okay, I'm gonna draw a little diagram here. It's gonna be really bad. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is solid. Okay? This is solid. Okay? Now let me write about it. Solid is nothing but all these hard parts, water bottle, all those, a door, all these stuff. Okay? A stick, anything. Now let's see some points about it. It's intermolecular space. It's about its particles, about its fixed shape and volume. Okay. So the first one is particles are very closely packed. Okay? Together. What's this? So this is the particles are very closely packed together. It just like this, just like this. You see here, this, yeah. Whoa. Just like that. That is. I know it's a little bad. I can't blame myself. Okay. So the next one. Alright. So the next one is the intermolecular force of attraction between the particles is so strong that it can't move. There we go. Okay, the intermolecular force of attraction between the particles is so strong that it can't move freely. It's a glue for a solid. Think of that. Intermolecular force of attraction is like a glue, okay? It just sticks into solid that it's so strong that it can't, get them out, okay? But in real life, it's not like that, not like glue or anything. It is a force of attraction between the particles, like it's swirling around them, telling them not to go out. It's like that. Next one. Solids. This is this is like a main point of solid, okay? Solids have a fixed shape and volume. And cannot be. What's that? Cannot be. What's that? Cannot be. So this means that the solids have a fixed shape and volume, and it's so strong that it cannot be compressed easily. Can you take a water bottle? Can you take a pencil box and can you just crush it? Can you just do that? You can't do that, right? That's what it is. That's what it's saying. Its solid is so strong. It has a fixed shape and volume. Okay, it's so strong. Okay. Next one. 1 minute. Okay. So the next one is solids do not flow and do not need a container to hold them. Everybody knows this, okay? Solids can only change their shape by force when cut or broken. Examples of solids are chair, computer, eyes, blackboard, and so on. Okay. So next one we're gonna do liquid because these points I don't think it matters that much. Oh, what's that? Liquid. There we go. So liquids, okay. It's like there we go. Up. Wait. Okay, so this is liquid. Sorry for my handwriting. I mean, like, it's really bad. I don't worry about pencils. Yeah. Look. Solid is nothing but, it's just like water and oil and all those liquidy stuff. Milk, what we drink, what we eat, yeah, those. Well, it's not mostly all of what we drink, but yeah, it's like that. Water, rain, everything. Okay. Okay, so let's get some points about it. The particles are closely packed. Less closely. No. Okay. Are less closely packed. In liquids than solids. Okay, so the particles are less closely packed in liquids than solids. If you see here, it's solid, it's all crushed and all together. But in liquid, it's not like that. It has some space to move, and it only has the particles are less closely packed. Whereas in solids, if you see, everything is mixed and it's there. Next point. The intermolecular force of attraction between between the particles is not as strong as in solids. Okay. So the intermolecular force of attraction, it's not that strong in liquids because the liquid, it's very watery. It's not able to move a little freely. The intermolecular force of attraction. That's why it's not able to bring it all together. Okay, and the intermolecular space intermolecular space for liquids is like it has some space. It has some amount. Is oh, what's this? I think I put the sentences wrong way. Okay. So liquids have some amount of intermolecular space to move. That's why we always see when we put water in the water bottle, it always, it shakes. It has some space to move. Unless we, fill it till the end of the water bottle. Yeah. Till the tip of the water bottle. Yeah. I don't do that. Alright. Let me just tell this, keep your eyes and ears open, okay? The force of attraction between the particles in liquids allows them to have a fixed shape, fixed volume, but not fixed shape. Liquids take the shape of the container which holds them. Yeah, you see? It doesn't have a fixed shape. When we put it in a container only, it gets that shape. You see, right? When you put some water in a water bottle or whatever kind of water bottle it is, it just gets that correct size, right? That's what it says. The force of attraction, It's a little calm with liquid, but not with solids. Okay. Next one, liquids can be compressed to a certain extent. I think we can squish liquid. Liquids can flow and need a container to hold them. Examples of liquids are water, milk, juice, coffee, and so on. Okay, let's move on to gases. Actually, I guess I will just, tell all the points to you because it's not that hard. Gases don't need to read or anything. Whoops, wait. Oh. Okay. And there we go. Alright. So gases is like very much out of the way. It's never together, ever. But it takes out, it spreads out. Imagine it's a team, a police officer. All police officers are going on a mission to get all the space. Yeah? And that's how it is in gases. It goes and occupies everything. If it's put in a container, it'll get all the space, but you cannot see it, okay? Let me just tell you everything, okay? Keep your ears and eyes open. It's not that hard. It's not that hard. The particles are very loosely arranged in gases and thus have large intermolecular space to move freely. Okay, so they have so much space to move. They're very loosely arranged, and that's why they can get, space to move freely. They can't even stick together, yeah? And like in solids, like in liquids, you can see solids. You can see them are like stuck together. In liquids, you can see them. They're just like a little bit further, not that much. But in gas, they're like so far. Yeah, this is air. Okay, air, oxygen, carbon dioxide. This is like a diagram of. Okay, so the next one is the intermolecular force of attraction between the particles is negligible to hold them together. Negligible, I don't know. You might not know what it means. I don't know why they used it. It's, it's a little not that strong enough to hold them together. Because if you see them here, they're just flying around, They Okay, next one, gases can be compressed very easily, okay? Gases can flow and need a container to hold them. Examples of gases are oxygen, nitrogen, carbon dioxide, and so on. If you see here, chimney, it has some smoke. There, you can example that is a container. You use these hospitals. If you go, you will see some containers of oxygen in them, or for people having oxygen crisis. It's really coming up these days. So yeah. You can see in the news there are so many oxygen, containers. Okay, that's all for today. Please, if you will enjoy this episode of education, please be sure to leave a like and subscribe and comment below. Okay, and yeah, I guess I'll see ya. You can't take screenshots, can you? Okay, let me just 1 minute. You can pause the video and you can read through all this and you can understand anything. Okay? So yeah, it's like it'll be a little easier to understand. Okay? Please be sure to subscribe and leave a comment below. And I think I'll see you guys in the next episode. See ya.